Hello everyone, today we are going to learn Geography 3rd lesson ICSE, that is rotation and revolution of Earth. All planets have two types of motion and Earth also has two types of motion. Earth spins on its own axis completing one rotation in 24 hours and this motion of Earth is called rotation. Simultaneously, Earth goes around the Sun also. This motion of Earth is called revolution. It takes 365 days and 6 hours to complete one revolution. If we connect north and south poles by a line passing through north and south pole, it is nothing but the axis of Earth. The axis of Earth is tilted at an angle of 23.5 from perpendicular to orbital plane, and thus the axis of Earth makes an angle of 66.5 degrees with a plane of Earth orbit. This tilting of axis is called inclination of Earth axis. So let's learn what is rotation. Rotation is turning around of the Earth on its own axis from west to east direction. But why don't we feel rotation of Earth? So if you think that you are in a jet or a aeroplane, if you see outside of the window, you can understand you are moving. But if you do not see, you think that you are not moving. The same reason can be applicable for rotation of Earth also. And let's learn some the main effects of Earth rotation. East to west movement. Since the Earth rotates from west to east, we see sun rising in the east and sun setting in the west. I think now I think you understood that why sun rises on east and sets on west. And now day and night. The most important effect on earthly rotation is dural, that means night, day and night. Alternation of light and darkness. As portion of Earth's surface is turning forward and then away from the sun, the variation is exposure to sunlight greatly influence the local temperature, humidity and wind movement also. And then circulation of air. This is also known as Coriolis effect. The wind and ocean currents are deflected towards right in northern hemisphere and towards south in southern hemisphere. This is known as Coriolis effect. And the fourth effect is that if you see the Earth, you can observe from a satellite, you can observe that a half portion of Earth is towards sun and which is at day and another part is at night. So the line which separate the Earth from daylight to night is called circle of illumination. Now learn what is revolution and its effect. So first, revolution is the movement of Earth around the sun, and now let's learn some important features of revolution of Earth. First is the Earth revolves around the sun from west to east. Here we can understand that Earth rotates from east to west and Earth revolves around the sun from west to east, and it takes 365 days and 6 hours. But we conveniently say that Earth rotates only 365 days, but the actual time taken to Earth rotate around sun is 365 days and 6 hours. And second point is that the Earth revolves around the sun at an average speed of 29.8 kilometers per second, or we can say 107 kilometers or 120,000 kilometers per hour. And another point is that the Earth orbit around the sun covers a distance of 965 million kilometers. And the last and final point is that the period taken by the Earth to complete one revolution around the sun is called a year. And now let's learn effects of revolution. The Earth completes one revolution in 365 days and 6 hours. For our convenience, we take only 365 days as 1 year, and these 6 hours after every 4 years we add this one extra day to February, which is known as leap year. So now the second effect is most important effect, that is changing of seasons. So now I will be showing you the four positions of earth while revolving around the sun. In the first position, if you see the equator, actually it is the equator is not directly exposed to the sunlight, and the south pole is away from the sun compared to north pole. So north pole experience summer in this time and south pole experience winter in this time. In the second place, you can see that the equator is at the topic of Cancer if the earth is not tilted. So the in the northern hemisphere is away from the sun and southern hemisphere is little bit closer to sun. So we can understand that northern hemisphere is facing winter and southern hemisphere is facing summer. In the third position, where all in these two positions the sun rays is falls equal towards to earth, so this is also known as equinox, which is our next topic. So first, so these two are rainy seasons or spring or autumn. In these two positions, mainly spring and autumn seasons are experienced in these two positions. So let's see the same the positions of earth. In the first position, the northern hemisphere experience summer. So in the northern places, the daytime will be more, and the southern places the daytime will be less. In northern, in the same diagram, the north experience more less night, and in southern hemisphere experience larger night. And well, when we go this side of earth position, the northern hemisphere experience shorter day and southern experience larger day, and northern experience longer nights and southern experience shorter nights. That is the point here it is explaining. So before the same pictures can be used for learning solstice and equinox. In before we learned the four positions of earth in changes of season. So let's take the same first position. In this position, the northern hemisphere faces towards the sun and southern hemisphere faces away from the sun. So the northern hemisphere experience summer, so the day will be more in northern hemisphere and the night will be less, and in southern hemisphere the nights will be larger or longer and the day will be shorter. And let's go to the second position. In the second position, the northern hemisphere is away from the sun and the southern hemisphere is near to the sun. So the northern hemisphere experience shorter day and longer nights, and the southern hemisphere experience longer day and southern nights. So this is nothing but solstice. Equinox, in the name equinox we can identify equal. So in equinox, the both day and night will be approximately 12 hours day and 12 hours night, which means the day and night are exactly equal or approximately equal. So that is equinox. Solstice can be observed in June 21st and December 21st, and equinox can be observed in March 20 and September 22. So let's learn about all these days in detail. So the solstice happens at December 21 and June 21. So let's learn about the date June 21 in detail. On or about June 21st, the noon rays from the sun falls vertically on topic of Cancer. This is because North Pole is tilted towards the sun. And the second point is that the northern hemisphere has longest day and shortest night, as we discussed before. As the earth rotates on its axis, all points lying towards north of 66.5 degrees north remains constantly within the circle of illumination and experience 24 continuous hours of daylight and the midnight sun. On the other hand, all the points of 66.5 degrees south are outside the circle of illumination. Thus, have 24 hours of continuous darkness. And the last and final point is in the summer the northern hemisphere, whereas winter in the southern hemisphere. As during this period, southern hemisphere is tilted away from the direct rays of sun and create a lower angle for incoming solar rays, and so the sunlight will not reach the southern hemisphere more. And now let's learn about sunset at December 22nd. On or about December 22nd, the rays of sun fall vertically on topic of Capricorn, or that is the parallel of 23.5 degrees south, which is also known as topic of Capricorn. This is because of south pole is inclined towards the sun and the north pole is away from it. The day is longer and the night are shorter in the southern hemisphere. As Earth rotates on its axis, all points lying south of 66.5 degrees south remains constantly with the circle of illumination and thus experience 24 hours of daylight. By construct, all north point north of 66.5 degrees are always outside the circle of illumination, thus have continuous hours of darkness. And the last point is, during this period the northern hemisphere is tilted away from the direct rays of sun, thereby creating a lower angle for incoming solar rays. And now let's learn about equinox March 21. The movement or the venicular equinox or March equinox occurred in March 20th 21. The March equinox is also known as vernal equinox. The rays of sun fall vertically at the equator is the second point. And the last point is that at that time the circle of illumination passes through both poles, so period of daylight and darkness are nearly 12 hours each all over the world. And now let's learn about September 23rd. The first point related to September 23rd equinox is both September 23rd equinox and autumnal equinoxes means same. It also happens when both poles passes through the circle of illumination. And the second point is that the rays of sun falls vertically at equator in this time. And the third point is all parts of the globe experience nearly 12 hours of day and 12 hours of night approximately. And the fourth point is that in autumn in northern hemisphere and spring in southern hemisphere is experienced. Now let's learn about about orbit. The orbit is the part of Earth around the sun is called orbit, and most of the people don't know that the Earth revolves around the sun in elliptical part. Everybody think the Earth revolves around the sun in circular part, but it revolves around in an elliptical shape or part, which means elliptical means oval shape or X shape. And you have to know two terms here, perihelion and ephelion. Perihelion, the Earth is said to be in perihelion when its distance from the sun is minimum, approximately 147 million kilometers. And ephelion, the Earth is said to be in ephelion when the distance from the sun is maximum, approximately 152 million kilometers.